Good afternoon. When I was asked to talk about this, I really hesitated because it's quite overwhelming. And I just ran across this comic, well, it's not really a comic, but it's a statement about this issue. It's interesting, the date that was on this comic starting 1990, that's basically when I first had to teach it in a course and when I first started learning about it. And, but it's been around since about 1897 when someone, from a scientific viewpoint, warned the world about the danger of some of these things and so on. But it's not high tech, and it's not something that is easy to deal with, but I thought it was important enough that since I was asked to talk about it, I'll talk about it for 20 minutes. Now, it's so complex in my mind in terms of how to deal with this that I decided to keep it as simple as I can, meaning only talk about a few aspects, because you can get sidetracked and overwhelmed with so many issues. So I just want to really simplify it. I'm not here to solve any problems. It's just to say, hopefully you're aware of some of these things, and that hopefully it stimulates a little bit of conversation and then further research on your part and take it from there. There's three things. I'm going to go through it quickly. This is not a scientific report. I'm not going to reference everything. I'm just going to say, here's some public knowledge on a few issues, and this is a few things you should know about it if you don't already know about it, and at that point, just take it from there, all right? So the first thing up there is, you may or may not have heard of this, something called the Permian Extinction. What's interesting is about 250 million years ago, the life on Earth almost ended, okay? And this is long before human beings. But it's interesting what almost caused it. These two gases there, carbon dioxide and methane. Okay, it's called the end Permian time, or the Permian mass extinction. Right? Then from there, I'm just going to move on to something called global dimming, which is a form of global cooling, and just talk about that really briefly. And then I'm going to talk about the thing which was supposed to be the theme, I guess, the idea of nonlinear feedback systems, and how this is really dangerous if you're dealing with a system like that. You got to be really, really careful. Okay, so we're just going to talk about the first one there. And this is taken from a basic museum website. It's nothing fancy. When did it happen? 252 million years ago. What went extinct? And this is amazing. 93 to 97% of all species on planet Earth. All right, it almost ended the evolution of life on the planet at the time. Okay, again, this is just from it's common knowledge. It's not really disputed or anything. And the things that interesting here is this happened actually in near Siberia. There's a lot of volcanic activity. I don't want to talk about the details, but the original thing that happened was there's some global cooling due to the soot, dust, things that go into the air. That tends to cool the Earth, block sunlight. But that doesn't last very long. All the dust settles, hits the ground, and what's left behind is the carbon dioxide. That's a gas. It doesn't settle right away. It stays up there for a long time. And what happened is originally there was a bit of cooling, but then the dust settled and the carbon dioxide heated the Earth up. So, but the carbon dioxide by itself heated the oceans up, but then in the oceans there is something else here which is related to the feedback, which is a secondary gas which is called methane. And this extinguished 93 to 96% of life on Earth. All right, and it happened. So it's a matter we don't want history to repeat. Okay, so I'm going to keep it as simple as I can. As I said, I don't want to get bogged down in some of the science. I'm going to talk about cooling. I'm going to talk about the triggering by carbon dioxide, and then feedback systems of methane, which can really amplify the whole problem and make it quite serious. This is the only science in terms of a couple things here. Global dimming, it's really simple. Sun shines on the Earth. If you have dust or aerosols are just suspended liquid and solid particles in the air and so on, the sun bounces off and goes back to space, and that's called dimming. It's really simple, all right? So if the sun bounces off things, dust, aerosols, and so on, bounces back, that's called dimming or cooling. The other thing that can happen is the sunlight goes all the way through, hits the Earth, makes the ground warm, and then the warmth, which is called heat radiation, also infrared, the warmth just goes back, and there's gases, and those are called the greenhouse gases. Okay, carbon dioxide, methane, and there's some others, but those are the two. And so there's two competing effects. Right? The sun can shine in, bounce off the particulate, aerosols, dust particles, cool the Earth, or it can be trapped, and these gases can act like a blanket, and those are called the carbon dioxide, methane, greenhouse gases. Now, this is actually dealing with global dimming. I don't want to talk about this, but I want to talk about this, all right? There was a scientist at the University of Wisconsin that thought there was something interesting here because never before had the flights in North America been grounded and canceled for 3 consecutive days. And so he was a climatologist at a university, so he did some research. And what he was interested in was global dimming. So he said, hey, we know that there's a little bit of dimming on the Earth because these are particulates, right, and dust from the airplanes that fly. And he said, well, we know some of the sunlight hits that and bounces back to Earth. And okay, that's just a picture from a NASA photograph of some, they call them contrails, no big deal, except that he thought maybe this cools the Earth a little bit. All right? And so he says, well, now, never again will they have an opportunity to do an experiment, because for 3 days, all the aircraft was grounded. So he said they collected all the data, and again, this is all available, it's public knowledge. Anyway, this is the graph, which is phenomenal when I first saw this. I first saw this a year ago. This was the temperature change in the North America, all right? And this is what happened when you just removed the jet contrails for 3 days. In other words, what happens if you get rid of those dust particles and some of those aerosols and let the sun in? Now, that's more than a 1 degree Celsius increase in 3 days. All right, we're trying to prevent that by the year 2100 to prevent catastrophic global warming. And if that's what happens when you remove the global cooling gases in the world, we have a kind of a not too pleasant problem with the amount of greenhouse gases up there. Now, we could repeat this experiment. We could ground all the flights on the planet Earth for a week or so and then see what happens to the Earth's temperature. But that's an amazing graph to see. And again, you can read all about this. It's not anything special. So I'm not going to go into details. But the point is that's phenomenal. The odds of that happening are incredible. It has to be due to that. It's never been seen. And I think in a 30-year period, there was one other time where they had that type of temperature fluctuation. Once the jets went back up into the air again, then there was a rebound and it cooled a little bit. All right, now, this is important because this is a graph of the real temperature of the Earth. All right, now we're only up about 0.8, but when I saw this first a few years ago, I thought, why is it cooling here? And why is it getting warmer? And then why is it sort of staying stable or cooling? And then it's getting warmer again. And there was something interesting happening here, is there was global cooling effects preventing the global warming. Greenland ice cores are really, really helpful, all right, because we can see the amount of aerosols from sulfur by just drilling the ice core samples. And then this here, it goes way back, but I want to start here. And there's a trend here. This is global cooling aerosols increased, right? And then it dipped down for some reason, then it went up and then it went down again. Now what happened is this was coal. Well, okay, the Industrial Revolution, late 19th century, a lot of coal was being burned, so that's coal. Right? Then what happened is there was a switch to lower sulfur oil, and there was also depression in the 1930s where there was less coal being burned, so it dipped down. Then what happened is the economy took off again, we burned lots of oil and coal, and then right here, in the late 1970s, the United States and Europe, they got tired of breathing polluted air. So they put in legislation to clean up the air so people could have rather cleaner air to breathe in the cities. And so by putting in that legislation, that's the pollutants went down a little bit. Now this only goes up to about the year 2000 or so. All right, now how does that relate? Well, let's go back to now, what do we have here? That's coal being burned, late 19th century. So the Earth is cooling. What happens here? We switch to oil, lower sulfur content, and then right here is the depression where a little bit of coal, less coal was burned because the economy slowed down. So that's the real global warming happening. All right, that was coal preventing it. Then what happened here, of course, is there was no regulations. Right here is when the United States and Europe passed legislation, let's clean the air for people to breathe. So you clean the air for people to breathe, get rid of the pollutants. That's the real global warming happening. And then something else happened up here. It's in the news. Why is it slowing down? It's slowed down. This is only up to 2000, but it's actually leveled off for the last 10 or 12 years. Well, there's something called the economic miracle in China. They don't have any regulations on the coal and the oil they're burning in China and India. So what's happening is the same thing that happened here. No regulations, no regulations. So China, mostly China, has prevented this graph from going up. If you take away the aerosols, I don't know what kind of graph you're going to get, but the graph would be a lot higher and a lot steeper. All right, so that suggests that what we've already done to the Earth in terms of the greenhouse gases is much more severe than what we've noticed. Now I'm just going to switch topics and say this kind of curve is not nice when you're looking, because we don't want a curve that's going faster and faster and faster. And that's what the actual curve is looking like. And I'm just going to talk about that really briefly, if I can get, there we go. All right, now, when you're predicting the future, it's really difficult in terms of modeling, because if you can just do, everything could go like this, or you can have something like this. This is what we don't want. We don't want something that accelerates. That's called a feedback system, where something happens which causes the process to speed up, and it speeds up and speeds up and speeds up and keeps going. So that's basically all I mean, nothing complicated. But the word feedback over there is what I'm going to jump into next. All right, we already looked at global dimming, so I'm going to look at just two. There's many, many feedback systems, but two that I'm going to look at. One is called albedo, one is called methane. And the albedo one is really simple. All right, albedo just means when sunlight hits something white, the sunlight bounces off. If it hits something darker like water, then a lot of the energy goes in. So water absorbs more of the energy, gets warmer, the white ice bounces off. Same thing here. If you have white snow, the sun bounces off. If you have darker plants and so on, it absorbs it. That's all there is to it. So if you have darker surface, you absorb more of the energy. Now, why is this a feedback system? Because if you have less ice, then you're going to accelerate the warming. This is Greenland. This is the albedo here over the last 10 or 12 years. And of course, there's less and less ice. So what happens is not only is it melting, but it melts faster and faster and faster because there's more green and there's more darker colors to absorb the sunlight. So every year that this drops, you have accelerated melting in Greenland, which is not a good thing to play with. The other thing is the Arctic, which I'm trying to get to. There we go. All right, this is a map of the Arctic. The red line there is the average 1979 to the year 2000 of what they call minimum summer ice. So it means September, when the ice is minimum, then it grows back in the winter again. This was the average between 1979 and 2000. This was 2012. That's a lot less white ice. So that means a lot of the sunlight hits the water, which accelerates the melting. So not only is it melting, but because there's more water and less white snow, that's called a feedback. It means it's going to melt even faster and faster. And again, that's a dangerous situation to get into because that makes the slope of that graph steeper, which we don't want to have. Now this is the ice volume. Not a nice graph. This is the graph here. Now there's been a lot of things in the headlines. Oh, Arctic ice rebounds, 60% growth in Arctic ice. Well, you guys can use your own eyes. That's the real graph. There was a rebound this year in 2013, but there was back here too. And so there and there and there. So every time you could have headlines saying Arctic ice is rebounding, growing, that's fine, but that's the plot. Now, who knows? Some people are saying that it'll be gone in the summer ice by 2016, 2017, or so on. And that in terms of volume, that takes a huge amount of energy, by the way, the latent heat of ice, to melt ice to that amount of volume. Now, that graph is not linear. That's what's called polynomial or exponential. It's speeding up. It's a feedback system. We don't want to have feedback systems. And this is the IPCC's projection in 2007. This is, they said, possibly if we don't change anything and we keep doing it, somewhere up here in the early 22nd century, the Arctic ice will be gone in the summer. This is the standard deviation and so on. This is reality. So obviously, reality is worse than what the scientists say. Right? This was 2012. This was 2013. This graph only went up to here, so I stuck in the two dots. Right? This was for ice area, which is similar to volume. All right, it's not exactly the same. But again, when you have a graph like that or a graph like this, you can start to get worried because it's not linear, it's starting to curve up. This is warming in the Arctic. All right? So now it's hard to predict futures and so on. So I'm going to switch to the last little thing that I think is important is methane. There's huge amounts of methane in the world. This is the coal reserves, oil and natural gas reserves for the world. Methane hydrates are basically methane molecules surrounded by frozen water, literally under low temperature and high pressure, but they're generally safe. Right? What I mean by safe, some people are trying to extract them because there's lots of energy and then you can burn it as a fuel source, and that's okay, I suppose. But they're generally safe. In other words, they're down there and they're not really going to bother us unless we go hunting for them and try to extract the fuel from them, which we can do, which is okay. But the part that we're concerned about is this stuff up here in the Arctic, right? Because when you warm the water, all right, you get methane plumes, all right? So the methane's in these hydrates, but if you increase the water temperature, then it can bubble out and go into the surface. And that's basically what can happen, and you get the methane bubbling out. Now, basically, you can have the methane. It's in something called permafrost, something with carbon in it. Normally it's frozen. Hydrates are stable. They're frozen really cold. But if you have shallow water and you heat up the water, you can instigate biological activity in the permafrost, which produces carbon dioxide, methane. You can also release the hydrates, which the methane can bubble out. Problem is, methane is a really, really powerful greenhouse gas. So you get what's called a feedback system. The methane can bubble out if you warm it, but then the methane makes further warming, which then makes further methane, and it goes and keeps going and going and going. It's self-propagating. Now, this is really dangerous again because this is real-world maps, right? The red is methane, yellow is methane, but the red is really high levels methane. This was 2010, the methane coming out of the Arctic. This was 2012. This was 2013. All right? So for some reason, the methane is increasing. All right? And at a rather rapid rate. Right now, it's at record levels in the Arctic. But anyway, now why do we really have to be concerned in terms of what's happening here? Okay, methane, that's not good. That's over the Arctic. Yellow is also methane. In the world's, right now, there's about 5 gigatons of methane in the Earth's atmosphere. Basically, it's something called the East Siberian Arctic Shelf. It's shallow water. The waters are heating up. It's melting. There's scientists have estimated about 1,700 gigatons of carbon in the hydrates in the permafrost in the water there in very shallow water. Now, if we want to double, which is not a good thing to do, the methane in the Earth's atmosphere, we just have to release 5 out of 1,700 gigatons, which is a very small percentage. All right? And there is that coming out right now, 2013, and it's really hard to explain that except that it's coming from probably hydrates. All right? This here is taken November 21st, 2013. This is the Kara Sea. This is over here. This is Laptev Sea. That's in the East Siberian Arctic Shelf, shallow waters, 1,700 gigatons of methane. That's really high levels, 1950 parts per billion coming out. So that's probably coming out of the permafrost or coming out of the methane, or sorry, out of the hydrates. All right? That was just this year. All right? There's another one as well. Okay, that's just another Google map. Laptev Sea, really, really high levels. All right, this is the graph coming just out of the East Siberian Arctic Shelf. All right, and again, it's going up every year. And the question also is not that it's just going up, that's not good, but what's that curve going to look like in the future if we keep heating up the waters? All right, and right, that's another map from Google Earth. All right, this was December 2nd, 2013. That's not good. All right, most of that's permafrost or hydrates. It's cold up there. Methane's pouring out. Not a good thing to see. All right, and all right, just keep going. All right, some people might say that previous map. Okay, why did it come out in December? Which doesn't, you know. Basically, this last summer, July 2013. All right, record warm temperatures right there. All right, so why is that important? Because well, this is now 4 months later, right? Well, that water goes up there, and you can affect the temperature of the water. So, sorry, there we go. All right, hopefully you're familiar with those. You heat up the water here. We had all-time record temperatures in the Atlantic last summer. 4 months, the water goes up there, and that's the methane that's pouring out of the Arctic right now from the warm water that went up there. All right, so there's a 4-month delay. Where's global warming going? Well, they're doing studies on the ocean. Most of it's going into the ocean. All right, this is July 2013, unprecedented warming in the deep ocean. So we do have a little bit in the atmosphere that we notice. All right, I just read yesterday, Russia had the warmest November in the history of their recorded temperature. It just was in the news yesterday. That goes back to 1880 or something in terms of for their whole country, their average temperature. But nevertheless, that's only a little tiny bit. This is where most of it's going. And that is not necessarily good for the ecosystems in the ocean, but it's not good for other aspects as well. All right? So a lot of it is masked, and that's not a good thing, whether it's by global dimming or whether it's by the oceans. Okay, and all right, basically is we got to be careful. This is where we are now. This is the Arctic, but when you project into the future, so far they've underestimated everything. You don't want to underestimate this kind of thing because it could be what's called a nonlinear feedback system. Once you get it going, they call it a runaway train because once you go beyond a certain point, you have no human technology that can stop it. And there's a certain point in there somewhere, we don't know exactly where human civilization will not be able to prevent it. It'll be self-sustaining. And you, of course, don't want to go that far. That's obvious. All right? So, but I don't think we are that far, but there's some warning signals coming out. This is methane for the last 10,000 years on planet Earth. Right? I was really amazed when I see this graph and people say, well, there's no proof that humans caused the methane. Anyway, this here started about beginning of the Industrial Revolution, okay, about 200 years ago. So this part here is methane on the planet Earth, right? And basically this is starting here, and it's going like this. Now, I saw this curving down here a little bit because methane degrades, turns into CO2 when it's in the air, it gets oxidized and so on. But so it's curving down, so hey, that looks good. It looks like it's hitting an equilibrium, and it would hit an equilibrium for the methane, except 2007, all right, we kicked in with the Arctic. That's the Arctic. So it was kind of leveling off a little bit, methane, still really, really, really high. And then, of course, 2007, the hydrates, permafrost, something started kicking in the Arctic, and that's not good either. That's a feedback system we don't want to kick in full, right? And so there's some things going on there. All right, back to the original cause of all this. Okay, CO2 is the original cause. This is what we've done. And again, I've read, oh, there's no proof that humans have done anything here. Well, this is the Industrial Revolution right here. And this was taken from Arctic ice cores. This was taken from direct measurements from a place in Hawaii. All right, this is where we are now. We just passed 400. Right, despite all the carbon budget talk, 2012, 2013 had record CO2 released in that year. And so people talk about their carbon budgets, but right now this is going up to off the charts. Now, this here, sorry, I want to go back one and then I'm done. Right? This here is someone's saying, well, this is what we have to do for all of human civilization. It's been around here. So we have to suddenly do something to the way human society runs to turn that graph around, which is going through the roof, and stop it and right down. So by the year 2100, we're back down to 280 parts per million, right? But we'll see about that. But anyway, that's someone's hopeful thinking. And then the last thing is civilization. This is basically the temperature, which there's ways of figuring this out and so on, from ice cores and so on. Human civilization basically started somewhere in here, whether it's 6,000 or 8,000 years ago, and we had a fairly stable climate. That's enabled us to flourish by having a stable, predictable climate. Now, it was actually a slight cooling trend there. Now, some people might say the world's a little bit too cold, you want to make it a little warmer. That's probably okay, as long as you do it slowly. This is what we've done. We're up here right now, all right? That's a rapid, unprecedented kind of change to the climate system. And where it's going to lead us, no one really knows. But what we don't want to do is where we're going this way. So to continue to go here by the year 2100, well, I don't know. People have different predictions on what can happen there. Right? What we want is we want a stable climate system. We don't want to be doing this. And that's what we've been doing. All right? And we're going that way. All right? Almost full speed ahead. All right? So again, I hesitated to talk about this. But hopefully it stimulates some conversation, stimulates some discussion about some of these things that are going on in the world. All right, so thank you for putting up with me. And okay.